Hello Pioneers, in the last episode of our Satisfactory series, we began automating fused modular frames with the help of nitrogen gas. Today we're focusing on turbo motors, a key component for unlocking Mark III miners and solving resource bottlenecks. To achieve this, we'll set up a water fracking site and add heat sinks and cooling systems to our production lines. Let's get started. To kick things off this episode, we have some signage to put up. So I asked you guys for names for this area, which is our bauxite processing facility that makes our aluminum ingots. And one of my viewers decided to come up with Alumaxor or Alumaxor. I don't know how to pronounce it, but it sounds cool. So this place will henceforth be known as Alumaxor. I'll put up a matching sign to enter manufacturer. Alright, cool. So let's get to work now. We've got a lot to do this episode, so let's get cracking. So we've recently unlocked leading edge production, which allows us to make the miner Mark III. Now the miner Mark III, beyond needing the basic stuff, also needs a couple of advanced products: the fused modular frame, which we've already made, the supercomputer, which also we've automated, and the turbo motor. The turbo motor is made in a manufacturer, and it requires rubber motor radio control units, which we have already made, but it also requires this new cooling system. The cooling system requires nitrogen, which we brought in last episode, water, which we've got to figure out a solution to bring to our base, rubber, and heatsink. Rubber we've covered, heatsink is a new product. Heatsinks are made in an assembler, and the materials are reasonably simple. Here they are. They just need the alclad aluminum sheet and copper sheet. So why don't we get the simple one going first, and we can sketch out a new factory area to do this. Now looking forward, I don't see any more raw processing in tier 7, do we? Let me just double check the last thing. I think the last thing all has to do with advanced nuclear power. I'm just wondering whether I should reserve the bottom section or the top section. So this is all nuclear stuff, and we're not going to do nuclear stuff in the current factory. The only thing is nitric acid. I wish I knew how to make nitric acid so I can decide. Well, if it's going to be done inside refineries for things like basic things like sulfuric acid and nitric acid, we can do them in rows of refineries here, I guess, if it's just going to use sulfur and base materials to make. But over here, I think, is a good spot to start the actual assembling stuff. I don't know. Because normally on the bottom floor we do base processes, and then above we do sort of assembly and manufacturing, but I guess in this advanced factories case we can just do it right here. Hard decision. I also need a factory section that's just wall. Otherwise, if I build this factory corner, I'm gonna get clipping on the wall. So I'm gonna remove one of my walls in my factory corner and update that blueprint to start with. Alright, we'll load up factory corner V2. Then does it matter which wall I remove? I think it kind of does because of the light orientation. Oh, these lights are just terrible. So if we were to look at it this way and we were to put that corner there, then it's this wall I remove. Wait. Let me just think about that. If we were to put this corner into this slot over here, then it's this wall I remove. But then when we rotate it twice, it's the same wall. Oh man, that's terrible. I think. I don't know. Let's just try it out. We'll save it there. I mean, you can have infinite blueprints. We just need like a better categorization of blueprints, and then we're actually pretty sweet. Because I'm just using subcategories at the moment, but there's also categories. So given how messy this is all getting, we should probably categorize all our blueprints a bit better. But for now, let's just try this out. I mean, I know it works. It's just that with the light orientation, it's just a little bit awkward. No, it won't work, will it? Because it will work on this side, but then it's not just the light orientation, it's the room top as well. Like the window alignment is not quite right, I guess. Factory needs a doorway. One of my viewers suggested double gates to seal the doorway. We can try that. We like to try new things, right? Which way should they go? Double gates? What do you guys think of double gates? Not a huge fan, but meh. We'll leave them for a bit. Variety is the spice of life. If you're enjoying the video and you want to support Data Engineer Plays, don't forget to leave a like and hit that subscribe button. And if you have any feedback or suggestions, feel free to share them in the comment section. So we'll load up our factory corner V2 again. Oops, don't want to save it. And last time we removed this wall, this time we'll remove this wall. And in theory, that should cover both, all 4 corners, right? I have no idea. I know my naming convention is terrible, so that should be the right side now for this. And indeed it is. Alright, cool. So let's lay down a couple of assemblers. Oh, and also someone told me that we can use the customizer to lay down the foundation. So fix it foundation swash. Concrete structure. Where is the swash for? Oh, materials. Ah, I see. And then we can, I see. So now we can make this coated concrete easily without having to replace the foundation floor. Okay, that's so much easier. Can we make this coated concrete? No. You can't make walls coated concrete, right? Yeah. We also don't want trees in our factory, so I'm gonna have to go down there and sort these guys out. Fantastic, we've got a new factory room with coated concrete and all that fun stuff. It's time to get our machines down. Now this should be our new assembler block with the inputs and the outputs on the right level. So we're going to do something like this. I think this is my standard build process. We'll get this one going with heat sinks. Now, in what volume do we require heat sinks? Let's have a look. Let's just go above and make our other 2 buildings. So one is a manufacturer, that's definitely going upstairs, and one is a blender. It's going to be blender, then manufacturer. So blender I haven't created a thing for yet, but maybe we should just go create a thing for it. Standardize it, you know? Since we've got this thing up anyway. Perfect. You can only fit 1 blender. Oh, check it out. Once a blender is on, you can't put lights up anymore. Lights clip the blender. Oh man, does that mean blenders need to go into a 5-story room? 5-story room would ruin my height consistency for everything. But then again, the 4-story room already does that, so... Alright, let's just make the blueprint for the blender and we'll worry about the lights in a bit. We can probably light around the blender, which I don't like that idea, but... it is what it is. I'm gonna do it a little bit forward. Where's the center point? This line is the center. I think that's the center point. And then we'll keep it in line with this thing. We'll get that going directly upward. It's so directly upward that it's basically in the ceiling already. They literally don't need wall plugs. They can just plug into one another. I'm keeping my 3-high room because I want to know where all the inputs and outputs go. So the way we've done the blender last time is... oh, let me just double check this so we can remain consistent. Well, I mean, I can always rebuild this blender. It's kind of fine. So the left one is the 2nd height. The right one is the 3rd height. And they're all going inwards. So like that. And that hits that 3rd wall. Now we can get rid of this stuff. Mostly. Sorry, I'm building my power on the wrong level. I'll leave the 3rd floor height in there. Because we're going to do other stuff, right? Because I want to test the piping as well. So say... just trying to test pipe heights. There's a cool thing about pipes, right? And the way that they travel is that they essentially travel right underneath a belt. So let's just test this out. So say in a room that we have a bunch of belts traveling on the 2nd and the 3rd floor, because that's where all our inputs are for our manufacturers and whatnot. Like that. The pipe part, if we use a pipe support, it should travel right underneath a belt. Like that. Right? And we can use that information to get the height of our 2 pipes. And then we will have pipes that don't interfere with the belts, in theory. Okay, I like that. I say in theory, and then in practice, like none of this is gonna work. So we've got to think tile-level blueprint, right? And in the world of a tile-level blueprint, oh, how's that gonna work? In the world of a tile-level blueprint, we're gonna need some sort of pipe support here, right on the edge of the blueprint. And we'll try to get it as close as possible without clipping. Probably one more out. And we'll just do one here, because they should share one, right? And then I'm sure we're gonna have to redo the piping, because if I tile a blueprint right next to it, this and this is not gonna connect to each other. But it should serve as a decent guide, right? And then we can shove this part into, and we can edit these blueprints as well later. Okay. Diagonally. And diagonally. This one is too far to sort of line up properly, so I'm just gonna have to eyeball this one. It won't even do this one. What? What do we think of that? I think that looks okay for a 4 input system. In which case we can probably delete these, because they're gonna just connect to the next valve part. And we can get rid of these, because we don't want that in the blueprint. In fact, we should just be able to remove these pipes entirely now, and then it just has the valve. Yeah, actually that works perfectly fine. And we can do the output. So with the output, we want it on the 4th level, so we can start removing some of this stuff. And then same with the pipe output, but it's going to look something like this. And we know we can delete this after, so we just put 1, 2, 3, and that should travel right underneath the pipe. Well, it's on a different elevation of pipe to this, isn't it? 1, 2, 1, 2, 3, 2, 4. 1, 2, 3, 4. Give it some different clearance. That should travel right underneath the belt for this 3rd floor. But we want it to travel right underneath the belt for the 4th floor, right? I think it's fine. Let me just validate that before I blueprint it permanently. Yeah, we want the pipe to travel right underneath that, because that is the height of the output, right? So we want the pipe to be like here. Which means we want a junction around here. Just like center ourselves here, and then put one directly going down like that. And then in theory, that should be perfect. Now, I don't know if it has the lift to do this, because that's actually quite a few meters upwards now, but we'll deal with those problems in the future. If we need to add some lifts, then so be it. Now we can remove everything out of the blueprint. And we should have all the basic connections of a blender. I think that's pretty useful. Let's put in all the fixins. So we need a merger that goes out that way. And then a splitter. It goes in that way. Then we just need power. Then we just need to remove everything. And there we have it. A nice clean blender blueprint with all the inputs and outputs for everything. Nice. Here we go. We'll call it Blender 1X. And we'll save the blueprint. Now blueprints menu, do a little edit and move that to the right spot. Alright, we'll leave the blueprint up in case we need to make any minor modifications, and we'll go set ourselves up a blender for the cooling systems. Okay, we'll put our factory corners in. There's 1, there's 2. These ones I'm just gonna, I think I'll just dismantle. Let's try the dismantle option so we don't have to make more blueprints. Just do 1. So if I just do that, will it dismantle both walls or just the one wall? It kind of semi-dismantles both walls. That's just super annoying. But then again, we do want a hole between the factories, so that is also a consideration. These aren't going to be separate factory rooms, right? They're kind of interconnected. So we can do that. And then we can carve a hole in the wall. Yeah, fair enough. We don't need this to be perfect because this is going to be all carved out anyway. There's not meant to be windows in between factories. I just thought of that, so typically a factory should look something like this. So put the wall in the right section. This is just to block out the different 16 by 16 bits. Oh, so bright and orange inside. I don't know if I like this. But yeah. There's some pillars on. And make this central entrance look a bit better. Oh man, we have so much work to do. Why are we wasting it all on design? None of this is important. It's just with the coated concrete foundation on the ground and everything looking so nice, I kind of feel like I'm obliged to make things look nice. An aesthetic factory is an organized factory. Alright, that'll do. Let's get back to work. Alright, we're on... Man, we've been doing so much random crap. We wanted to make a blender. That was the purpose of all this. It's gonna look something like this. Now we want to give the blender as much space as possible because we're gonna need it. Yes, we're gonna be building on the coated foundation part for the pipes, but what can you do? Because we need another space for a manufacturer on this side, so we're gonna have to utilize as much of the factory as we can. The blender is going to be making the cooling system. And then there's going to be a manufacturer here to turn all of that finally into the turbo motors that we actually need. Now, where's the alignment here? Yep, that looks about right. That doesn't look right. Oh, it's cutting a bit close. Both sides is cutting a bit close. 16 by 16 rooms are a little bit of a stretch for these machines, I think. So we want this to make our final product, the turbo motor. And I do not think we're going to be making more than one of these. Clock them down to 50%, the equivalent to one machine. Oh, I hate that because now all my numbers are halved and I got to keep that in mind. You know what? I'm going to clock this to 100%. We'll clock it down to 50% at the very end because otherwise all my numbers are halved. Alright, I'm going to work out these numbers. So to get the volumes for the heat sinks, we'll have to work backwards. We need 7.5 cooling systems per minute. One makes 6. I feel like I just want to make just barely enough. They do fit side by side quite nicely. Now we're going to test if our design actually works. So our target production for this is half of 7.5. Which is 3.75. That way 2 of them will make exactly 7.5. We'll hook up the inputs and outputs later. But what we're interested in is this number. So we need 7.5 heat sinks per machine, which is 15 heat sink. So let's go down to the heat sink area and set that up. So each one makes 7.5. That means we need exactly 2 machines, which is what we have. That's perfect. That'll make the 15 heatsink that we require with absolutely no excess. Alright, we might as well get the heatsinks going. So the alclad aluminum sheet, we're going to need 37.5 times 2, which is 75, I believe. Verify that. Everything's going to be undersupplied until I can increase everything, but that's fine. Let's double this up. Because that's free. We've got enough ingots to double this up, I believe. Why is this one capped out? Yeah. We definitely have enough ingots to double this up, so let's do that. Now that's going to consume 120 of our ingots. We can actually have enough room for another machine. But that should be producing 120 now. And we've got to update the copper. So we've got 45 left. Whoa, it's super dark. Head over to copper smelting, and I believe that this one is supplying that. And now, why is it on 50 already? They take 10 per minute each. And I've got 4, so it's on 40. I don't know what I was thinking there. Oh, I wrote 50 as in I was gonna make 5 machines. Alright, so I don't need to update that. We'll leave it on 50, just to confuse our future selves. Also, do we have enough fused things to unlock the next thing? Oh wait, we need turbo motors, don't we? Our last thing in particle enrichment requires turbo motors. Yeah, alright, fair enough. Anyway, back to the task at hand. We've got the alclad aluminum for that. Let's check out the copper sheets. We need 2 machines, 22.5 each, which is 45. Copper sheets are being made on the 3rd floor. We've got available 20, but we're not going to extend right now. So we needed 45, and at the moment, with our current production, we're going to be down 25. That's fine, I think. Well, first of all, rifle ammo is not constantly being produced, so that 15 doesn't exist. AI limiters would be, but we do need to extend copper sheets. Is that possible to do in our current infrastructure? Yes, because we have plenty. All right, let's just extend it if we can. I was going to say don't bother doing it, but if we can do it, why not? The ones that require more stuff, we're not going to do. Let's just remind ourselves what they're currently doing. Each copper sheet maker is... Wait, that's our copper wire maker. What am I doing? So currently each... Wait, what? Am I going insane? Going on the wrong level. There we go. Copper ingots to copper sheets. 20 ingots become 10 sheets. We're currently producing 120. We need to go up to 160. So we're going to extend this again. We'll use our old constructor blueprint to match this. Make sure we flip it in the right orientation. Line it up. We're just going to do 4 more. And when we connect everything and set the recipes, we should be sweet. That was reasonably easy. I'm assuming these are all idle because copper sheets are back. Fantastic. We'll keep our notes all updated and tidy. So now we're producing 160. And we should have 15 available for storage. Then that should increase our copper usage by 80. So that'll go up to 320. And we should have 80 left. No, 110 left. Yep, that all checks out. The only thing is the ingot input needs to be a Mark IV belt, because there's no way a Mark III belt can keep up with that, right? Make sure that entire line is Mark IV. Yep, that looks like it's correct. The Mark IV belt coming in, and then it needs to be a Mark IV belt of ingot coming across. It can be a Mark III belt coming out. That doesn't really matter because it comes out at half the rate it goes in. Alright, we've sorted out everything for the heat sinks. We just need to bring it across now. I believe copper sheets are right here, so we'll use our standard pattern. There's a smart splitter. We should really blueprint this thing, because we're going to be doing it a lot now. But then I don't know how to do the conveyor hole thing down the floor. So we basically want that. That looks about right. It hides the entire lift. Let's chuck a conveyor hole here. And then into the hole it goes. Get a lift going this way. And then into the lift. That looks about right. We'll tell the smart splitter that the center is overflow and the left is the main line. Now we can go underground and bring the lift to the other side of the world. Bit cluttered over here, so we'll go underneath and we'll drag a belt. Now we need to figure out where this goes in and out for the heatsink input. So we'll try to use as much of the middle as possible, I guess. It all comes out on the 2nd floor here. So we need 2 inputs. One of them is this, isn't it? So it's this sheet. Let's get the sheet in first. That makes the most sense. We did a priority split over here for the sheets. Let's go. This is the worst splitter I've ever designed. So it's going in this way, and on the right hand side we want that to be any. And instead of going out this wall now, we can fix this wall and we can get it going out this way. It's gonna go through this thing, but so be it. And like this. That sounds like a terrible idea. Get it just going through this one. And then that can go in... Ah, interesting. We can clear this belt, actually. By bringing it this way, we can make it clip a lot less. I mean, when I say clip a lot less, it's still clipping quite a lot. I'll be fine. As little clipping as I can get. And we'll wrap that belt into there. Our next belt goes into the wall. We can decide which one to use. I guess this one is as good as any. And that's going to go down and get the copper sheets now. Conveniently, the copper sheets line up nicely. And that's both our inputs in. Next thing to deal with is power. Which is not as easily said as done because of these stupid lights. Putting the lights in the floor was a bad idea. Guess we'll just put it here. Then we'll connect that through. Just like that. And now we should have a wall plug to connect to the outside power area. And now our heat sink's online. Nope. No power. What have I done? What is this wall plug? Right. Alright, now we should have power. That one's not configured. Alright, that should get us all the heat sinks that we need at the 15. And 15 are being used for the cooling system. Let's put in a sign that denotes that. Do I have any rhyme or rhythm for these signs? Not really, but I just stole the settings from the other sign. And we can set that. Oh, it's so pixelated. What the heck? Why is it so pixelated? Oh well, as long as they do their job. Our production number is 15, and for the cooling system, it's using 15, making availability of 0. Yeah, that's kind of cool. However, that was the easiest component to do. Now things are going to get tricky. Because now I've got to do the actual cooling system. The setup for the cooling system is the water. The water is going to be the tricky thing. So let's figure out how we can get water. So we'll set up a hypertube that goes out that way, because that could be handy. Got our lovely hypertube entrance. Shove that here, I guess. Connect that to power, and then we'll start running our hypertube. Now from experience, we know that we're going to run out of pipes. So we'll grab a few stacks of pipes, and we're off. Alright, you know the drill. Why is this thing confused? Did I set this up backwards? Yes, I did. A smart person would have put the entrance on the other side. Or the... would have put the entrance with the power pole, but apparently I'm not a good designer, so my entrance looks like this. There we go, that works. Alright, I'm gonna hook this up to up there, and then I'll be back when that's done. You guys don't need to see this. And just like that, our hypertube is now connected. Let's give it a little test. Always got to test our work. Now we have a nice little hypertube that accesses that section of the map. Now, why do we need to go up there, you ask? Because we need to get water into our base, and I'm thinking of using the station that brings the nitrogen since it's not doing very much at the moment. And we have the ability to frack for water now. Just going to grab a couple more radio control units because apparently they're required for the fracking machine. Now, I know there's water on the other side, over here, but I have no way of bringing that water in. There's water here too. I guess we could just pipe the water straight from here. Actually, that's probably a better idea. Why did I set up that hypertube? Let's check out the water on this source. Where is it? How have I never seen a water geyser source over here? Oh, it's literally right below us. Okay, never mind. I've got a new plan. Let's just use the water that's already at the base. God, that was silly. Where can I bring power down? It's on this tile, but it covers one of the water wells. I'm going to start setting up the water extractor. I'll be back when that's done. And voila. Here is our pressurized resource extractor, and here is our little well extractors. I've done this little pipe system that sort of wraps around the main thing, and that way all the little satellite things can come into it. I've set up 5. So it should tell us that, well, we can actually drop this down, right? I don't trust it. So yeah, this can potentially do 780, but we've only got 5 of these things, so it should be doing 600, which is a full Mark II pipe of water. I've done that because I don't know what other things I might need water for, and then that's going to go do a loop-de-loop around this pipe. I've set up some valves to tell it which direction to go, and then from there it should go up through this, and we're using a Mark II pump to get it to go up back to our base. So now our water is in our subfloor. We can route that somewhere. We'll use a pipeline thingy. That way it will route in between our belts. I think that's a good idea. And yeah, we just need to bring that into our base now. That will be the second component of the blender. So let's go get a pipe down from the blender, and then we'll see how that routes back into our new water source. That's great. We can use water for a lot of things in our base. There's a lot of alternate recipes that use water, so it's super handy. But this thing requires water and nitrogen, so we need both sources. And we've got nitrogen over here already, so maybe we should route the nitrogen first, because that's already coming up and in. So we just need to split this and bring it in through here. So we can use this one, and well, where's the pipeline wall hole go though? How does this interact with this wall? The pipeline wall hole literally goes in between. Oh man. So it goes like that. That looks disgusting. Can we put one here? No, think so. Doesn't even like that. Has to go on the edge. It's about there. Close enough's going to be have to be good enough. Let's just make sure that this is not consuming all 600. It's consuming quite a lot. We've got 2 of these, right? 93 times 2. It's consuming like 200 of the nitrogen gas. And this thing's consuming like 37. Alright, we're still good on nitrogen gas. Now to get this aligned perfectly, we need to get over here, align it to this, and then shift it out 1, 2, because someone taught me that's how you get perfect 90-degree angles, and they are correct. Then that should line up perfectly there, and that should line up perfectly there. That tells us that the next wall hole is going to be directly above it, which is here. And then can we put a wall hole that aligns with that? Apparently we can. Fantastic. I'm not going to color this yet because of all the valve issues and stuff, because I remember when we color things and we have to like redo the piping, it screws everything up. So there's our pipe system. Ideally we remove these supports, but then people have told me that after you remove supports, pipes don't work anymore, so we might just keep the supports in there and we'll get the pipe going through the floor. That does take up a weird and awkward amount of things, but maybe the pipe can travel directly in between 2 conveyor lifts. Who knows? We'll have to see. But if we're using pipeline supports, in theory, I should just have to put a pipeline support right in the middle here. Not the middle, but... oh, these design patterns are really getting to me now. So it's not on the edge, it's like 1 offset from the middle should be the correct straight distance down. Yep. That's perfectly straight, right? There you go. And now this pipe intersects with this pipe, which is, I guess, gonna be a thing, isn't it? And we can get the pipe to run perfectly against the top. And our thing is over here, so let's bring that across as well. So we're going to join to the pipe over there somewhere. Why is the pipeline support just like 1 tile off from being a full thing? It's so weird. I think it's okay. I think it's the distance of the incline that's causing it to be a little bit short. But theoretically, we should be able to get it to this tile now. And then we can turn it. Like that. So this roof is actually the wrong level. Yeah, it goes up. Okay. That's better. Damn you trees. Get out of my way. Okay, we'll get it there. And then we'll get it in. And yes, it intersects these pipes, but come on. That's too difficult to manage. We're not going to do multi-level stuff in the subfloor. In theory, that should get water going. It's going very, very slowly. Oh, here it comes. It's actually not going that slowly. It's going quite fast, actually. Pump's doing its job. Alright, we got water in. We did need water, right? The cooling system needs water and nitrogen gas, so 2 of them are in. Now we just need to get the heat sinks and the rubber. Well, the heat sinks are right downstairs, so let's do the easy one first. Naturally, they go out this, but we don't want to use that middle section whenever we can avoid it, so it's going to have to go here. Now, I don't know if it's required to be stored. I haven't seen heat sinks needed for any sort of building material at the moment, so we're not going to store it. The input for the heat sinks can go, I guess, to the top, to the 3rd level. It's pretty arbitrary. There we go, that's our 3rd material in. We'll probably connect this stuff as we're doing it. And boom, we got heat sinks. And our final material is rubber. Rubber is an interesting one because it's kind of right here, but we don't have a splitting mechanism for it. Because at the moment, this is where technically the rubber is going out. We want it to come out from after this. So where it's coming out here into this splitter actually is perfect. Is this a smart splitter? No, it's just a regular splitter. So I guess that's going into the subfloor then. Yeah, the design of all this is completely inconsistent and a little bit weird, but it works, so I'm not going to complain. So we got a lift hole going over here. Should be able to get a thing going down without the lift portion at the bottom, and then we can go underneath the subfloor to sort that out. Our subfloor is becoming an entire thing now, which is good and bad, I suppose. Let's add more subfloor then, and we will put it on blueprint mode so we don't screw this up again. That way everything snaps together nicely in a 4x4 grid. We'll look for this conveyor hole and we'll bring it out that direction to keep it consistent. We don't want to run things like across here. Well, the ceiling line's not being used, so we'll follow the ceiling, I guess. Oh no, our subfloor has finally hit terrain. That's also not a good thing. What is this janky pipeline connection? Why does it suddenly turn and do weird things? That's my main nitrogen line, by the way. Oh, and there's more trees in the way. A lot of fun stuff going on. But in theory, we should be able to get rubber out like this. Then we can follow the ceiling. Or the roof. Ceiling. Ceiling is interior. Roof is exterior. Alright, where is the end of the main road? It's over here somewhere. So let's bring down a line for where we want this thing. Probably going to be here. We want it coming out the 2nd level. And we'll just use the free vertical right next to it. Now it's going to connect that ceiling level, so it's this level, I believe. Let me just double check that. Nope, that's not right. Need to reverse this as well. I think it's this level. That's still not right. Oh man. This level? That's flat now. So probably around the edge over here. I'm going to drop this pipe a little bit because it's having issues now. We'll do the janky connection over out here. That way the rubber has full clearance. So the rubber's over here right now. We want it to bring it across directly above here, basically. And then in. It does not like that because I've done this in the wrong spot. And in. And there we go, we've got rubber. Is that everything? I believe it is. There we go, nice and clean. Nothing's clipping at the moment. Alright, so we've got all 4 materials in now. We just need to get the power. Do the power along this line. Hook the machines up. Hook the machines to wall power. Get the wall power up. Have a look. And there it is. Cooling systems. And both machines seems to be functioning. We've got to hook up the rubber. Got to hook up the outputs. And there we go, cooling systems. Now I don't think this is used for any construction, I don't believe, so I don't know if I need to split it for anything. Does it tell me if it's used for building stuff? It's used in turbo motors, and then it's used for a space part, but it's not used for anything else. What if I look at, for example, iron plate? Does it tell me that it's used for... Yeah, it will tell me if it's used for other stuff, right? Like floors and things. No, it doesn't. It just tells me for equipment, damn it. So it doesn't tell me if the assembler needs it or something. Alright, well, I guess we'll amend it with a smart splitter at some point and send it into storage if it is used for other stuff. At the moment, we'll assume it's not used for anything. So that's making 7.5 cooling systems. Let's jot that down. And it's being used in the turbo motors at 7.5. That's what we configured it to, isn't it? Yep, so the turbo motors take 3.75. Wait, no, that's radio control units, alright? 7.5. Fantastic. Alright, let's go jot down the rest of the notes of what's being used up now. 7.5 rubber times 2, so 15 rubber is being used here. That leaves us with 70 rubber remaining. Not going to jot down the nitrogen gas yet. We'll do that in a bit. But yeah, that's all the solid components. Now we can worry about our last thing. We have everything. Cooling systems, radio control units, motors, and rubber. The only thing we need to bring across is motors. So let's figure out where we're going to do that. There are 4 solid components. So 2 on this floor, 2 on this floor. Well, if the cooling systems are right here, we should probably bring them down. And then we'll figure out which input is best to wire that into. Maybe we'll bring them down 1 floor and get it into this one. That's 1 down, 3 to go. Next is rubber. Rubber is also right here, and it's on this level, convenient. So if we put in a splitter here, we can get them into one of these inputs. That's nice and easy. That's 2 down, 2 to go. The next one is the radio control unit, which is also being produced right here. Is it on this level? I believe it is. It's right here, and it's being split out there at the moment, and it's on the 4th level. So we can use the 4th level to get it through this wall. There's going to be a little bit of clipping now, but I'm okay with that. I know the 4th level is meant to be for output, but we'll bring it down here now to the 3rd level. And there's going to be a little bit more clipping, but it's going to go into here. We'll get it into here, actually. We'll get that one going into there. And that should sort itself out once I turn it on, hopefully. And we'll get that one going into there, leaving one last output here. So we need to get that out the wall. So it's going to go out this wall. It's important to do these things in order. That way you know which is the best input and output for each thing. So we'll get that going like that. And now we need to bring the motors here. This whole thing might as well just not even be floor, because it's all going to come from underneath, right? So we'll get the motors going underneath like this. Looks like a reasonably free channel. Now we just need to go to the other side and figure out where motors go. Or where motors come from, I should say. I believe they're right here. That's the, they're all like next to each other. Fantastic. So we just got to do this system once more. Seen it a million times now. That's all lined up. That's all lined up. Get that going up to the right level. Get the motors going in. That looks good. Get that going this way. Configure it so that the overflow is in the center and any output goes out to the left. Get our conveyor hole in. Get that going like that. And we'll get that coming down to the ground floor. We'll run a belt across. This logistics system under the subfloor that I've set up seems to be working out for us so far. I don't want to jinx myself though. A little bit of clipping is going to happen here because where's the thing? Actually, no clipping is going to happen because it needs to go here. Fantastic. And there we go. We got motors in. That's pretty much all 4 components. Now we just need to add some OH&S things. And then we just got to hook up the power, I think. All right. Go outside, hook up the power to the main grid. And just like that, everything is online, I believe. Yep, I know we're going to have an issue with RCUs because they're taking it from 2 different inputs. Or just the fact that, wait, we need to get the smart splitter prioritized. Because it won't send RCUs that way. There we go. Now some RCUs will be sent that way. But, of course, we are not producing RCUs in the quantity that we require, right? That's going to be a whole thing, but that's fine. We'll get at least some turbo motors. That way we can upgrade some of our miners and upgrade some of our output. But that's going to have to be prioritized. But at the very least, it's being constructed now. 1.875. Well, we have 3 summer sloop left, so you're getting all of it. Now we're producing 3.128. 3 point something, whatever. So, yep, that's pretty much the basics of it. Let's set up a sign. Without the summer sloop, we're making 1.875. Now this thing is supposed to consume 3.75 RCU, which puts our availability at like negative 1.25, right? Or something. Doesn't matter. We'll extend it very, very soon. We just need some RCU to make our Mark III extractors. Or Mark III miners. That's pretty much it. We've got everything. So we need to store the turbo motors into a box somewhere. Coming out here. So they're going to go out here. We need to smart split them somewhere. I'll line it up with one of these wall holes. And we can get that in. And get that outer wall. And we'll just do the main one first. That should be able to go in here, right? Yeah, that's... So the center output is going to be the overflow. And then we haven't defined any other output for now because we just want them to overflow out. So we've got one motor there. Has it only made one motor this entire time? Yeah, because it's lacking a lot of radio control units, which is fine. Let's just chuck some in so that it starts producing them quickly for now. I know we're not producing enough to support it, but that's fine. Now we just need to get that into a box. The box height is this. So that's flat and nice. Very good. All right, now we need to get that over and into a box around here. Yeah, we're going to give this a little bit of room, so we might put it somewhere here. No point cramming ourselves in if we don't need to, right? Everything seems to have worked out so far, but I don't want to jinx myself. Maybe if we position the box with the correct input and output direction, things will work a lot better. And just like that, we've got our first turbo motors ready to use. Hello, turbo motors, where are you? I have no idea. It should be producing, right? Let's just double check. Yeah, I see some coming out. Yeah, I think everything else is good. Cooling systems, motors, rubber. Just the radio control units is undersupplied, so we'll fix that next episode. But I think we've done quite a lot this episode, so we might call it here. But we are getting our first turbo motors at a decent rate as well. And we're going to need it next episode because we need to tune all of those terrible inputs that we've done, because a lot of stuff is undersupplied now, and there's no way for me to fix the supply without increasing the raw ore production that's linked to everything. Because at the moment, everything is tapped at a Mark 4 belt, but with our Mark 3 miners, we should be able to double that now, and everything should be all good. Oh, look at our max production. Our max production is creeping ever so close to our power system. So we definitely need to maybe do a power system episode before we do that. And I have an idea on how to do that, but we will have to explore that next episode. We're very close to nuclear power as well. So we can skip my idea for the power system, or we can do it. But when we get 50 turbo motors, we should be able to unlock particle enrichment. But then again, all that extra stuff for particle enrichment is going to take a lot of nuclear power, and I'd like to be in a comfortable power spot before I turn on nuclear power. So next episode, we might go exploring on our power systems to make sure that we can generate sustainable power, because at the moment we are very, very reliant on our geothermal power to keep us above the blue line. Not that we're using any very close to our power. Our constant power usage probably is under 5,000 at the moment, and we're producing probably around the 8,000 mark consistently, or the 9,000 mark consistently. So we're actually reasonably okay with power, but it's better to be way oversupplied with power than to cut it very close, have our entire power grid go offline, and then try to figure out how to get that all back online, because it's going to be a pain in the bum. But we're in a really good spot now. We're actually producing everything. Ah, there we go. There's 200 cooling systems required for this unlock. But I mean, unless it's going to unlock something other than this, I don't really want to store it. We don't really have any excess. We'll just take the cooling systems out from the turbo motors, I guess, to do it. Let's go do that before they all get consumed. I'm sure cooling system will become a requirement at some point, but for now, we'll just chuck it in here. I think I had some extra cooling system somewhere. Nope. Do have an extra hard drive. Let's go get that scanned. Oh, last hard drive's done. Leached copper ingot. So we can reduce the consumption of copper ore, add some sulfuric acid, and get even more ingots in a refinery instead. Or we can use rubber and this to make cables in an assembler. Okay, I guess that's more useful. Scan another hard drive. We'll leave it here for this episode. Hope you guys have enjoyed. If you don't want to miss out on our next video, don't forget to leave a like and sub. And I'll see you in the next episode. Thanks for watching.